All right, let's go through our numbers 8 through somewhere around 14. So we'll see how this goes. So here we had a problem that you were estimating the difference in the average, or let's see. Oh, based on their reading speeds. Okay, so they were given a passage to read and then the time in seconds. So it was a difference in the average amount of time to read the passage, having sugar minus the sugar-free. Okay, so looky here at this difference in the average reading time. So that means the sugar group has an average that is 5.8 seconds less than, up to 0.15 seconds more than the sugar-free group. So again, remember I do this in terms of both. So the average reading time for the group that took the sugar is between 5.8 seconds lower, because it's negative, to 0.15 seconds higher than the sugar-free group on average. Okay. But the key is, because there is zero, there could be zero difference. So there could be no difference. That's why B is then the answer. We do not have convincing evidence one way or the other. All right. Number 9. So this was another one that we had to then know and understand this formula. It was a proportion problem because it was 16 out of 40. So I was pulling the proportion formula for 2. And then we had to do 99% confidence interval. So if you have 99% in the middle, then you have 1% split. That's a half of a percent. That is 0.005 when you do inverse norm of 1 tail. So that's why the critical value was 2.576. Next, here we had a 90% confidence interval. Now this is a problem for means. It is about the average projected career earnings for college graduates with degrees in education. So there you go. So make a 90% confidence interval for the average. So I can also confirm when I look up here that, so look at the information I've been given. I've been given the sample mean, that's the X bar, the sample's standard deviation, that's the S of X, 0.4. So then the sampling distribution's standard deviation is 0.4 over the square root of 25. Okay, because 25 was the sample size. Now, if I want to then get my critical value, because see, look at here is the formula that you need to do the interval. So there is your sample mean right here. The critical value comes from inverse T of 1 tail. So if I'm 90% confident and I have 90% in the middle, then I have 1 tail. So 0.05 and 24 degrees of freedom, because in minus 1. So that's how I got 1.71. And so there's that number, and then here's the S of X, 0.4 over square root of 25. Alrighty then. See, that was one where you had to know the formula, and you had to know how to do it by hand. So here we had one. In order to kind of think through this, I have to kind of think through the hypothesis testing process. So this was a problem asking on average, let's see, the viewers, they're seeing if there's convincing evidence that the television viewers remember more than 4 commercials on average after watching a 30-minute program. So that's the null hypothesis, is that they remember 4 on average. And the alternative, we want to see if they remember more. So they got a p-value of 0.15. So I know this p-value is greater than most reasonable alphas, because the biggest that typically happens is 0.10. So I'm going to fail to reject. So I will have no evidence of HA. Okay, no evidence that the average is greater than 4. So now I go find that because the p-value is greater than. So I'm looking for not convincing evidence that the television viewers remember more than 4 commercials on average after watching the 30-minute TV program. So these other ones, this one it is greater than, but it says there is convincing evidence and so on and so forth. There is. Okay, so those were out. All right, moving on. So now we have number 12. So this is a problem where, once again, look at this formula that you had to wade through. So here we wanted the interval for 2 independent means. So this piece right here is the difference between the 2 means. So the x bar 1 minus the x bar 2 or whatever. Okay, and then we have the critical value, which in this case, they gave it to you. All of those were the same, so we didn't have to mess with that. That's good. And then, looky here. This was from the formula chart down here with the means right here. So I just followed that and could see it was that one right there. All right, so that was it. So see, needing to be able to follow those formulas. And number 13 here, let's see. We've got this problem where you had to compute. Now, they just straight up gave you the interval. So this was a 1 proportion z interval, and you are welcome to do that by hand. But as I mentioned earlier on problem number 2, this is a problem that you could have done in your calculator if you wanted to with a 1 proportion z interval. So here with stat over to test, that would have been going on down because see all of the tests in the menu are first, and then we get to the interval. So a 1 proportion z interval is A, and so then I filled in the information for that problem, 68 out of 400 with 90% confidence, and that came up with my answer as well. So, be aware of how to do it by hand, okay? And I'm going to let you just take a look at that, our sample proportion. And then look, here was our formula for proportions. And then our critical value, inverse norm of 1 tail for 90% confidence, it was 0.05. All right, and let's see here. Oh, this is an interpretation of confidence level. So confidence level. So remember that on this interpretation of confidence level, we anything that contains the confidence interval is out. Here is just kind of a general information for confidence level. If we sampled many, many times, if we repeated many samples, then how many, we would expect about 99%, and what size interval of all the 99% confidence intervals to contain the true parameter, the true population proportion, or the true population mean. If it talks about containing a sample, it is out. It is out, it is out, it is out. So A is gone because it talks about containing a sample. And this B says it's containing the proportion of all registered voters who plan to vote for the Republican candidate. So that's the population amount it is describing. The other ones just don't make sense. Okay, so that's why B is better than A. All right, we'll go ahead and go through 15 and 16. So here, I want to take a moment to talk about this one a little in depth. So we'll go ahead and stop the video there where we just ended with number 14, and we'll start the next video at number 15.